Mr. Vinay K. Srivastava, Adjunct Professor, Department of Metallurgical Engineering and Material Sciences, IIT Bombay. Good afternoon.
Thank you. Thank you being here in Indian Chemical Society conference and workshop and good gathering here at Nehru Center. And thanks for calling me for a small, what is my impression about the whole. So I'll be happy to answer. Please just go ahead with the questions so that I can answer you in a discreet manner. Thank you.
You have been focusing on new material at Department of Atomic Engineering,
Yeah.
as well as IIT Bombay. So if you can talk about your contribution to the Indian chemical industry.
Well, Indian chemical industry and society as a whole is very old. Anyway, we are celebrating 100 years. If I talk about the nuclear materials itself is a big family, so probably that's not right now a platform to be talked about. But nuclear family or nuclear materials are too big in general. And but if you talk about in general chemical industry, I think we have been in the impression just to export the raw materials and get the finished product. But now the whole impression is totally changed. We have developed the processes. We can process them here itself from the raw material to the finished product and be on the exporter side. So this is a changeover which has taken place for the last more than 30 years or so in our chemical industry. But I can say chemical industry in India has been very old, including when we call it about sugar technology, we call about nuclear technology, we call about, say, even paper and pulp technologies, everything. But nowadays, most of the things are totally indigenized in the way. We are now trying to help many SAARC countries. We are also trying to help many neighboring countries, and also being a collaborative partners and helping them by way so that we can grow together. So.
You are also working on graphite. Uh, what are its new use cases that you are planning to develop for the chemical sector?
Well, I think any chemical industry as a whole cannot be left over without no emissions of various obnoxious gases. They, because of challenges, no, it should not cause harm to the environment. So they need to be rather stopped within the system, or they be scrubbed before they are left over in the environment. So that all these things are trying to. So graphite materials have been found very, very comfortable and useful where elevated temperature and corrosion problems exist in the chemical industry. So many other materials which have been tried, they have been found neither not only a failure but also a low it's a life of those materials. And this graphite has found not only very, very compatible, but also giving a larger life to the equipments. And so that way, I think this has taken a shape, and India has been importing earlier. Now with this development in my own industry, nowadays we are not only doing for the Indian markets, but also trying to export to our neighboring countries this product. So the graphite-based monoblock heat exchanger, graphite-based scrubbers, graphite-based systems like acid dilution systems, and HCl production everywhere. Means the graphite blocks has got a very much acceptable, as material of construction. So I think it is a growing market, and I can say in the coming days, graphite's a new product you will see in the market in the form of graphene, which is again a challenge which has got another wider applications. More, I say, maybe I can say, next stage of graphite is going to be a graphene. So it is a challenge, and India is also trying to do in those lines. Thank you.
So, do you also have the tubing technologies based on graphite?
Yes, we do make that. We also making that, and most of the pipes and tubes that we do is not by extrusion, but by way of casting. We try to do it, and now required for say vessels and required for our own plants wherever necessary, we do it. So we have got a complete solutions to the plants nowadays. We are trying to supply, and mostly that inorganic acids, they are like sulfuric acid, nitric acid, and hydrochloric acids, and there is this challenge, and graphite has done a very good job for them. So, and this, and along with that, like sulfur dioxide and nitrous oxide gases which is being emitted, and many like BF3 gases being emitted by the industries. So it's a big challenge, and highly obnoxious and corrosive. So they need to be scrubbed before they are just thrown in the atmosphere. So they are everywhere. Graphite is doing a very good job for us. Thank you.
So what kind of processes are you looking for these heat exchanger technology as
Actually,
graphite?
most of the people are well familiar with the cell and tube type of heat exchangers. And monoblock has got a double advantage. One is that is not only compatible in terms of material, but also in terms of the hydrodynamics design that we do. So, and also we can do simultaneously both the things, like many times when we do as a scrubber and dilution system. So both say dilution as well as heat transfers can take place simultaneously. So at the same time, concentration developed from the top to bottom or bottom top can be designed. So that is how this has found that from hydrodynamic point of view, this has given very good advantage. So that way, I think when people think of say cell and tube type of heat exchangers, and so monoblock heat exchangers has got a very good advantage. Probably I do teach sometime in the classes that how hydrodynamic designs of such heat exchangers are beneficial in terms of pressure drops and also in terms of the total absorption capacity and efficiencies. So that is how it goes on. So
Cost-wise, definitely graphite would be on a higher cost.
no. It is a misconception. Graphite is not that very costly, and if you look at in the terms of gain that you get in terms of the life of the equipment, I think you'll find that you are on the beneficial side. So not that way. Only thing is acceptance. As you know, we are traditional people in many fields, and so also in the chemical industry. So when we change over from one concept to other concept and new materials, so it doesn't come so easily. So acceptance has now taken place, and gradually it is growing that way. So otherwise, but certainly it is a specialty applications wherever corrosion and elevated temperature both are their problem.
And in your field, what are the future technologies which will make an impact in India's chemical sector in the next 100 years?
Well, I think I must say, because as a chemical engineer, the roles goes in all walks of life. People have been thinking like basic chemicals, specialty chemicals, toxic chemicals, and many more. And I must say nowadays we call it nuclear chemical technologies, and also we call it nowadays a very simple, which is we call it a desalination technology. And everywhere chemical engineering plays its own role. So I myself being rather having done not only in thermal technologies of say desalination, membrane technology of desalination, then starting from even recovery of uranium from phosphoric acid, and then also going to the last way how to recover the lithium 6 out of the lithium 7 from the lithium ores, and which is required for fusion reactor of the program. But even this is something, where chemical engineering and chemical process industry has got wide role to do in future. As far as the graphene and graphites are concerned, well, this is a new materials which is a very much coming in demand, and a lot of experiments are being conducted based on graphene. You'll find maybe another couple of years that graphene will have its own market in terms of new and specialty challenges fields.
For EV, you need a lot of lithium. So, do you see any alternative of lithium in years to come?
Well, I cannot comment much on the lithium in general, because lithium is having two isotopes. One is lithium 6 and lithium 7. I have been more focusing on lithium 6, which is just 0.75% on the total. So otherwise it is lithium 7, which is being used for general, battery purposes. So my expertise goes the other way. But anyway, I think India, as far as the extraction of lithium is concerned, and not only that, even rare earths also are in many counts, they have done plenty of process development, and we can say we are self-sufficient. Only thing, yes, the supports everywhere in all aspects becomes very important to compete in the global market.